Okay, in this short introductory tutorial, I'm going to introduce the concept of combination circuits. A combination circuit is where you have part of it is in series and other parts in parallel. There can be multiple combinations of parallel and series. I'm just going to build the simplest one, talk about some of the highlights so that when we go to tutorial, you'll see how these basic facts are applied to slightly more complicated situations. Also in the process, I'll show you how to quickly, but on the notes, it'll be more formal, how to do effective resistance of a combination circuit. Okay, so let me build one. So I've already got started with my voltage source. So I'm going to add 3 bulbs that are in combination, not quite all series, not quite all parallel. So I've already got things started, so I'm going to turn the corner here and I'm going to add my first light bulb. And what I want you to understand is this light bulb is necessarily in series with the battery. It has to be, because if I'm starting at the positive terminal of the battery, I have to pass this light bulb to eventually get back to the negative. There's no alternative there. Okay, now I'm going to go, before I complete the loop from the light bulb, I'm going to create a branch. So I'm going to branch up and I'm going to branch down, right? So at that point, I'm basically making a junction. Okay, they're not going to be evenly distributed, so just let me add some wires. I'm making it not unnecessarily longer, but just so it's cleaner. So I'm going to add a bulb here, and I'm going to add a bulb in this branch, and then I'm going to connect these 2 branches together. And let me just do this, and I'll connect. So I'm going into this bulb, I'm coming out of this bulb, and then I'm just going to connect those 2 together. So when I'm coming from the battery, I have to go through this bulb. It's in series, and now I'm splitting up, and these 2 are in parallel, as ugly as that looks. And then I can add a wire here, and then just complete the circuit. Okay, so before I complete the circuit, I'm going to put a switch here. And I'm going to ask you to make a prediction in a second. Okay, so again, this is a combination, series and parallel. This bulb is in series with the circuit, with the battery when I say that, and these 2 are in parallel with each other, so I have 2 loops to get from positive to negative. Now, these bulbs are the same resistance. I believe they're all 10 ohms resistance by default, so keep that, I'll put values there, that's helpful. And I'm going to change this voltage to 15 volts for reasons we'll see in a bit. Okay, so first thing I want you to do is when I close the switch, predict how the rankings or how the bulb's brightnesses will compare. Okay, this is an exercise you have to be able to do. In fact, I'm going to do an activity later in the week to put this into practice for more complicated. Okay, so again, when I turn this on, these are all the same bulbs. They're connected to the same voltage source. How will their brightnesses compare? Okay, this is 1, this is 2, this is 3. They're all equal. One's brighter than the other. Some may be equal. So go ahead. I'm going to pause this for 5 seconds. Okay, so let's turn on the switch. All right, so if you haven't noticed, this is the brightest by the size of the rays. And these 2, if you look closely, are the same brightness. Okay, so I'll hopefully predict that, but if you didn't, let's explain why that must be. The simplest explanation, there's an alternative way of explaining it, that this is the brightest is because all the current must go through it. Okay, so if all the current goes through it and it has a particular resistance, its power is simply I squared R. Whereas when we get to this junction right here, the current splits. And in fact, since these are the same resistance, they get half the current. So this gets half the current, this gets the other half, and that adds up to the whole. So we'd expect these by I squared R to actually be a quarter of the brightness because it has half the current. But you don't necessarily have to do that. Okay, so that's a common explanation. A more complicated explanation is look at voltage drops. This has the biggest voltage drop across it. Because in essence the resistance of this is twice the resistance of this branch. Okay, since these 2 are in parallel, their resistance is 1 over 10 plus 1 over 10, and that's 5 ohms. Right? There's a shortcut since they're the same resistance. I can just say 10 divided by 2. So this branch has 5 ohms, this branch has 10 ohms, so this has the bigger voltage drop because it has the bigger effective resistance. Okay, and that leads us to the last thing I want to talk about. What is the effective resistance of this circuit? It's not 10 plus 10 plus 10, 30. Okay, so I've already given you a hint of how to approach it. The approach is I take everything that's in series and I add it up, because we know resistors in series add up, and then I take the parallel branches and reduce them to one resistance and simply add it to what I already have. So let me put that into practice here. I've already got 10 ohms here, so I know the effective resistance of the circuit is 10 ohms plus the contribution of these two. These two do not contribute 20 because they're in parallel with each other. So as we already said earlier, these two reduce to 5 ohms of resistance. So if they reduce to 5 ohms resistance, then these two, this branch, this whole thing right here, which I can't highlight, is in series with this. So 10 plus 5 gives us 15. So what I'm saying is the whole circuit feels 15 ohms of resistance. And since we have 15 volts, then we can predict what the current is in the circuit in the series part. So 15 volts divided by 15 ohms effective gives us 1 amp. So let's take our little sheet and put it here, and let's see what we get. And sure enough, we get 1 amp. 1 amp, 1 amp, 1 amp, all the way through. And then when we get into the branches, we should expect it to split into even parts. A half an amp, and then back to 1 amp. Okay, so there's combination circuits introduction for you.